learners, I am Professor Munish Kumar Bharadwaj, and today I'll discuss with you risk assessment for scaffolding. The content of today's discussion is, first I'll discuss with you the importance of risk assessment, then terminology related to risk assessment, then process of risk assessment, and finally hazard identification. The learning outcomes of this lecture are that after going through this lecture, you should be able to express the importance of risk assessment. Also, you should be able to define various terms related to risk assessment. Then you should be able to explain the process of risk assessment. And finally, you should also be able to explain the hazard identification process. Now let us begin the topic. So, as far as the risk assessment in scaffolding is concerned, risk assessment in scaffolding works is a crucial process that helps ensuring the safety of workers and the successful completion of a construction project. Scaffolding is a common feature on construction sites and presents various risks including falls, structural failure, and environmental factors. Today, I shall discuss the important aspect related to risk assessment for scaffolding works. Now, first of all, let us discuss the importance of risk assessment in scaffolding. Risk assessment in scaffolding is of paramount importance due to the inherent risks associated with working at heights. Ensuring the safety of workers and preventing accidents in scaffolding is critical, and risk assessment plays a key role in achieving this goal. Let us see the main reasons why risk assessment in scaffolding is crucial. So first thing is worker safety. The primary objective of risk assessment in scaffolding is to identify and mitigate hazards to ensure the safety of workers. Falls from scaffolding are a great significant risk, and proper assessment helps prevent accidents that can result in injuries or fatalities. Then second point is legal and regulatory compliance. Regulatory bodies and government agencies establish strict safety standards and regulations for scaffolding. The compliance with these regulations is mandatory, and risk assessment helps construction companies meet these legal requirements. So that is the importance of risk assessment. Then next point is reduction of falls and injuries. Falls from scaffolding are among the leading causes of construction site injuries and fatalities. Risk assessment identifies potential fall hazards and enables the implementation of safety measures such as guardrails, fall arrest systems, and proper access points to reduce the risk of falls. Then next point is minimizing liability. By conducting risk assessments and implementing safety measures, construction companies can reduce their liability in case of accidents. This can help protect the company from legal actions, fines, and financial losses. The next is resource allocation. Risk assessments help allocate resources efficiently because resources are precious. By identifying high risk areas and focusing resources on these areas, construction companies can optimize safety measures, training, and equipment use. The next important point is project success, means the success of the project. Ensuring the safety of scaffolding, workers contribute to the overall success of construction of project. Because when there is no fear, workers can work with more concentration, with more speed. Unforeseen accidents can cause project delays and cost overruns, both of which can be mitigated through effective risk assessment. The next point is improved productivity. Workers who feel safe and secure on scaffolding are more likely to be productive and efficient. Reducing the risk of accidents lead to a better work environment and improved morale. Then next point is environmental protection. Risk assessment in scaffolding is not just about workers' safety, it also includes identifying and managing environmental risks. For example, the risks of materials falling from scaffolding that could damage the environment or pose a threat to the public. The next important point is reputation and brand image. Demonstrating a commitment to worker safety and responsible scaffolding practices can enhance a construction company's reputation and brand image. Clients, stakeholders, and the public are more likely to trust and support companies with strong safety records. Then next point is emergency preparedness. Risk assessment includes planning for emergency situations such as rescue in the event of a fall or scaffold collapse. If we are prepared for these situations, we can save lives and minimize casualties. The next point is quality assurance. Scaffolding that is constructed and maintained with safety in mind is more likely to be of higher quality. Quality scaffolding is essential for the safety and productivity of the workers. So this way, we see that risk assessment in scaffolding is essential for safeguarding workers, ensuring legal compliance, minimizing accidents, and maintaining the overall success and reputation of construction projects. It is a proactive and systematic approach that contributes to a safer and more productive work environment. Now, let us see some terminology related to risk assessment. The first thing or the first term, basically important term here comes is hazard. What is hazard? A hazard is defined as any condition, substance, or activity that has the potential to cause harm or injury to people, damage to property, or have a negative impact on environment. So here we are covering three things: impact on people, property, and environment. Hazards in construction can vary widely and are typically associated with the dynamic and often dangerous nature of construction work. Let us see some examples of hazards in the construction industry. First hazard in construction industry is falls from heights. This includes fall from ladders, scaffolds, roofs, or elevated work platforms. Then next is structural instability. It is related to the structural integrity of buildings and temporary structures. This can involve collapse of walls, floors, scaffolding, or excavation cave-ins. The next hazard is electrical hazards. Exposure to live electrical wires, poorly maintained electrical equipment, or unsafe wiring. Then another hazard is fire hazards. Construction sites often involve in welding, cutting, and the use of flammable materials, and these all increase the risk of fire. Then next hazard is tripping and slipping hazards. Uneven surfaces, cluttered work areas, and wet or oily surfaces can lead to slips, trips, and falls. Another hazard in construction industry is noise and vibration. Prolonged exposure to high noise levels or vibrations from equipment can result in hearing loss or other health problems. Now, let us move to another term, risk. What is risk? Risk is defined as the likelihood and potential consequences of events or situations that could result in harm, injury, damage, financial loss, or project delays. Risks in construction projects can vary widely and should be identified, assessed, and managed to ensure the safety of personnel and the successful completion of the project. Now let us see some examples of risks in construction industry. First example is safety risk. In safety risk, first we cover fall risks. The risk of workers falling from heights such as scaffolding, ladder, or roofs. Another risk is structural risk. The potential for building structures to collapse or fail during construction. Another type of risk is environmental risk. This again covers different types of risks. One is weather risk. Adverse weather conditions like heavy rain, storms, or extreme heat can disrupt construction activities. Another one is related to regulations, that is environmental regulations. Risks related to non-compliance with environmental regulations leading to fines and project delays. Here, workers are not affected, but the project is affected basically when the company is fined and ultimately it may cause the project delay. Then another risk is design and planning risk. First is design errors. Errors or omissions in the project design can lead to costly revisions. Then risks associated to planning, that is planning risks. Inadequate project planning can result in delays and inefficiencies. Then another type of risk are quality risks. In this type of risk, we cover defects and the flaws. What are these? Construction defects, poor workmanship, or the use of substandard materials can compromise the quality of the final product. Then regulatory risk. First is permitting and licensing risk. Delays or denials of necessary permits and licenses can disrupt construction. Another one is code compliance risk. Failure to comply with building codes and standards can lead to rework and delays. So these are different types of risks. Now let us talk about the process of hazard identification and risk assessment. This process of hazard identification and risk assessment involves 4 steps basically. First step is hazard identification. In this step, various hazards that could impact the project as well as the health and safety of the workers are identified and separated from those that cannot, because there may be various hazards. Some may affect the workers' health as well as the project, and some may not. So we have to identify and separate these hazards. This requires a review of all hazards and their causes to determine whether they may be a threat to the project and the health and safety of the workers. This may require the consultation of the stakeholders, historical records, and government agencies. For each construction activity, a method statement has to be developed. Based on the method statement, potential hazards are identified. Number 2 is risk assessment. After having identified the hazards, now we calculate the risk per hazard. In this step, the level of risk for each hazard is examined. This may involve speaking with hazard experts, researching the past occurrences, and the possible scenarios. The likelihood of the hazard occurring and potential impact of the hazard on people, property, the environment, business and finance, and critical infrastructure should be examined. The next step is risk analysis. The information collected in the risk assessment step will be analyzed in this step. The desired outcome of the risk analysis is the ranking of the hazard. This highlights the hazards that should be considered a current priority for your emergency management program. Now, next step is monitor and review. It is important to remember that a hazard identification and risk assessment is an ongoing process. It is not that one-time activity basically. It's an ongoing process. And hazards and their associated risks must be monitored and reviewed from time to time. Now, identification of hazards. How we identify the hazards? What is the process basically? So, start by identifying all potential hazards related to scaffolding. The common hazards include fall from heights, then structural instability, then falling objects, then weather conditions, for example, wind, rain, then electrical hazards, then inadequate access or egress, means access to the scaffolding. How the workers will access the scaffolding, how it will move up basically. The reasons for these hazards may be unsuitable or faulty material of construction, inadequately supported scaffold boards, improper platform width and thickness, then non-securing or bracing scaffold to the structure, then damaged or wrong couplers that are used for making the connections between the different components of the scaffold, then unsecured ladder slipping, then omission of guardrails or toe boards, means they are missing, overloading the scaffolds, then erection on uneven ground. These are the reasons. Now let us see the methodology of hazard identification and risk assessment. The methodology of hazard identification and risk assessments shall include a step and time frame for identifying and assessing the hazards. What is this? One must define the steps for the identification of hazards and a time frame for this identification. means this cannot go unlimited. There has to be a time frame for that. The following information should be included. What is that? First is, who will be the responsible for identification? Means who will identify the hazard. For example, it may be the workplace health and safety committee, or it may be an individual, or it may be individuals appointed by the committee. So these will be responsible for identification of the hazards. Then the question arises, the way in which the identification reports are processed. Okay, the hazards are identified. Now, in which way these reports are processed? For example, they may be compiled and processed by the committee or by individuals appointed by the committee. Then the time frame of hazard identification, that how much time this process will take, that has to be decided. Then record keeping of the hazards. After having identified the hazards, one must establish and maintain an identification record either in print or in electronic format. Then a time frame for reviewing and, if necessary, revising the methodology, because we have to review the method from time to time, and if needed, then it should be revised also. So the date for the review of the identification, for example, the review of the identification method will be carried out every 3 years. Then techniques for hazard identification. To complete hazard identification, one can use various techniques to identify hazards. Some examples of techniques include, but these techniques are not limited to. Whatever I am going to tell you, these are not only the techniques, but these are some of the examples. First is workplace inspections. Second is task safety analysis or job hazard analysis. Then third is preliminary investigations. Then fourth is potential accident factors. So let us elaborate the workplace inspections. Conducting workplace inspections for hazard identification in scaffolding is a critical aspect of ensuring the safety of construction workers and the successful completion of construction projects. Here is a step-by-step guide on how to conduct such inspections. Number 1, prepare for the inspection. What does it mean? Ensure that the inspector is knowledgeable about scaffolding safety standards, regulations, and best practices followed in the scaffolding. Gather necessary tools and equipment, including inspection checklist, personal protective equipment, a flashlight, and a camera for documentation. Then second point is review documentation. Review relevant documents such as scaffold design plans, risk assessments, and prior inspection reports to understand the scope of the scaffolding work and any identified hazards. Then third is schedule inspection. Plan inspections at appropriate times, such as before scaffold erection, during scaffold assembly, and at regular intervals during use. Frequent inspections are vital because this only can help in reducing any failure, any risk. Then fourth point is inspect the scaffolding structure. Examine the overall scaffold structure for general condition and stability. Check the foundation and base plate for stability. Inspect the scaffold's vertical and horizontal members, including frames, braces, connectors for damage or signs of wear. The next point is assess the platform and decking. Inspect the scaffold platform boards and decking for integrity and proper installation. Ensure that there are guide rails, toe boards and mid rails in the place. Check access and egress. Examine the scaffold's access and egress points to ensure they are safe and in good condition. Then review load capacity. Verify that the scaffold's load capacity is not exceeded and that materials are distributed evenly. They should not be concentrated at a point. No large or heavy load concentrated at a point, rather it is distributed evenly throughout. The next point is inspect guardrails and fall protection. Ensure that guardrails, fall arrest systems and personal fall protection equipment are correctly installed and are in working order. The next point is identify electrical hazards. Look for electrical hazards such as power line in proximity to the scaffolding and ensure that proper precautions are taken. The next point is examine environmental conditions. Consider the impact of weather conditions on scaffolding safety such as wind, rain, snow. Ensure the scaffold can withstand environmental forces and stresses. The next point is document findings. Document all the findings including photographs of any identified hazards or non-compliance issues. Use a standardized checklist to ensure a thorough inspection. The next point is address hazards and issues. If hazards are identified, take immediate corrective action. This may involve halting work until hazards are addressed. The next point is communicate findings. Share the inspection results with relevant personnel, including workers and management. Provide clear instructions for addressing identified hazards. The next point is retain inspection records. Maintain records of all inspections, findings, and actions taken. These records are important for compliance and future reference. Then, next point is follow-up. Conduct the follow-up inspections as necessary to ensure that identified hazards have been properly addressed and to verifying ongoing safety. Workplace inspections for hazard identification in scaffolding should be a routine part of construction site safety procedures. Regular and thorough inspections help prevent accidents, maintain worker safety, and ensure compliance with safety regulations and industry standards. Now, let us summarize all the details that we have discussed. So, in this lecture, I discussed with you the importance of risk assessment. Then I discussed various terms and terminology related to the risk assessment. Then I discussed with you the process of risk assessment. And finally, I discussed the hazard identification process. I hope you must have enjoyed this discussion. Thank you.